Ladies and gentlemen, good afternoon or good morning for our American friends. Welcome to BIOKET Digital. My name is Johan de Koning from IA, the French Bioeconomy cluster. And I'm very happy to welcome you for this first webinar of 2021. Today, we are going to explore new challenges and opportunities for the bioeconomy through recent technological advances to improve bacterial strain and alternative protein production. For those who haven't heard yet about us, IA, the French Bioeconomy cluster, we would like to invite you first to discover us through a small video.
IAR is the French Bioeconomy cluster. Let's find out the 7 services we provide you to support your innovations. Tomorrow's solutions are being developed today, from ideas to endorsement and funding of your projects. Our expertise and strategic support will be there to maximize your success. Do you want to diversify your activity to reach a new market? Through our research and consultancy services, we analyze, explain, and help de-risk your business and innovation environment, enabling you to make strategic decisions and identify early adopters and clients. Bioeconomy is a European priority. Having been in Brussels since 2008, we can make sure your voice is heard. We are your ideal partner to access European funding. Innovative startup? Our Investors Club is seeking projects like yours. Thanks to our help, reach out to venture funds and raise the necessary funds to boost your project. Speed up your growth and overcome technological hurdles, thanks to the innovation platforms of our ecosystem. Our Bioeconomy Leaders Network offers you unique business opportunities. Meet your future business partners and develop your expertise at the many events we organize throughout the year. Conferences, business conventions, tech days, so many opportunities to increase your visibility and promote your activities. Grow your business abroad and give your ambitions new horizons thanks to our international missions and delegations. Brazil, USA, Canada, India, Southeast Asia, we will enhance your tech and business partnerships. In a changing world, we will help you adapt your training courses to the needs of bioeconomy. Access tailor-made skills, from the endorsement of your training classes to posting jobs. IAR services are here for you. Find out more on en.iar-pole.com.
Located south of Paris, Genopole is a leading biocluster in the Paris region. They have a strong expertise in technology, assessment, life science research, investment analysis, marketing, and business development. They offer services with the aim of providing qualified technical and scientific support to research activity, to biotechnologies, and to biotechnology startups and growth companies. Today, we are partnering with Genopole for this webinar, and we would like to thank them all and all the invited speakers for having accepted the invitation to share their expertise in today's topics: bacterial strain and alternative protein production. Before starting, I would like to share with you our program for the coming weeks. March will be a very busy month as we have several events for you. The most important one is the digital edition of BIOKET. BIOKET is our event dedicated to process technology to turn biomass into high-valued molecule. Due to the pandemic, the edition will take place in a digital format. During 3 weeks, you will be able to discover more than 60 technology dispatched in 12 sessions available on VOD, 3 live sessions, a startup village with at least 15 startups, plus a lot of networking moments, such as digital face-to-face meetings and thematics chat rooms. 3 weeks for the bioeconomy to do its show. An opportunity as well to meet Genopole. They are one of our main sponsors. They have a digital booth and they organize a live session on March 18 dedicated to the synthetic biology. So stay tuned to get more info on the program for our major event. Not to miss neither, on March 9, our webinar dedicated to the purification of plant proteins. A webinar organized in partnership with Eurodia, a leading company in the downstream process lines. Should you be interested in using our channels to promote your technology, your services, or to communicate around a research project, we are at your services. Just contact us to discuss your needs. Before giving the floor to Laurent, today's chairman, I would like to thank Nail and Annabelle and all the people that have been working hard to make this webinar happen. Its success is yours. Laurent, now it's time for you to take the floor and to share your screen.
Thank you, Johan.
Sorry. Yes.
Oh. Okay, thank you. Is it okay?
Almost.
Okay.
It's okay now. Perfect.
Thank you very much. Thank you, Johan, for this nice introduction. So let me talk a little bit about Genopole for you to understand what we are doing. As Johan said, we are in the south of Paris, 30 kilometers from the Eiffel Tower. It's not so far. And we are outside Paris, which is a good location for company if you want to reach Europe from there. Genopole is a leader in biotech, biotechnology. We have been created in '98. We are working in all kinds of biotech environment, so can be medical, industrial, environmental, agricultural, food, and marine. And we are working to develop a nice and friendly ecosystem for companies. Our mission is to support biotech and innovation. And so we have three main training area for companies. So shaker for small project, booster for to incubate companies, and also a development training course. Currently, we have three major scientific and industrial sectors where we are going to develop these three sectors. The first one is innovation therapy, second one, computational genomics, and the third one is bioeconomy, which is the topic of today. As you can see on this slide, this is a Genopole campus. So we are in the same time a biopark and a biocluster. As you may see, three companies are going to talk, are part of this campus: Ynsect, nextProtein, and Altar. They are all located in the same area, which is campus 1 and campus 3. In this campus, you have many kind of companies that are located in this area. Currently, Genopole is home of 83 companies. We have 17 academic laboratories and 26 platforms. Those platforms are interesting for company because you don't need to buy everything. You can use our platform that they are located in our Genopole campuses. We have more than 2,000 people working directly on this campus, and we have raised almost 1 billion euro in 14 years. This is some example of companies that we have on the campus. As you can see, we have big guys like Illumina, like Santen, like New England Biolabs, so means American and Japanese company. We have also Farming, which is a Dutch company. And also we are growing the bioproduction area and the FoodTech area in our campus. Of course, we can attract many kind of companies on the campus. We have one incubator for small and startup company. We have modular space for more mature company on the campus. And of course, we have also a business center. Thank you very much. So now to illustrate our position in the bioeconomy, let's show us a small movie. Joanne? Okay. Joanne,
Genopole, a scientific hub of excellence in all biotechnologies areas. Genopole is here to help you explore the applications of engineering biology. Set to become one of the new bioeconomy key players, Genopole focuses on turning research into solutions and developing the creation and growth of businesses. Genopole supports young researchers and gives rise to scientific leaders, opening new fields of research. Genopole's actions for bioeconomy development are far and wide.
Thank you very much. In the future, we'll need to find new food, and innovation is one of the answers. So Genopole wants to be a major player in this game. So today with three companies, we are going to show you how recent technology can help the bioeconomy in this challenge. So we will start with Ynsect. the famous Ynsect. So if you have watched the Super Bowl, you know everything about Ynsect. But let me introduce to Frank Pierre, which is the R&D director of Ynsect. Frank, is your turn.
Okay, thank you, Laurent. So we share my screen. Perfect. Okay, so according to this webinar, Ynsect will introduce the session, and our objective at Ynsect is to reinvent the food chain. So we are completely accurate, let's say, for this kind of webinar. As a first step, I will introduce a bit Ynsect company. So Ynsect company have been created almost 10 years ago with by 4 people. We are located in 5 different sites in France and in US, and we are located also in every Genopole. It's the place of our R&D center, and headquarter in Paris, part of the headquarter in Paris, a factory in Burgundy. A new factory that we are building at the moment north of France, and we are also located in US. We are at the moment 150 people employed, with 250 at the end of the year, with average of 30 years old. We have more than 50 awards in different areas: innovation, new business and economy, and management too. And we partnership with different academic and non-academic organizations, around 30, perhaps a bit more. And we lead some major projects at the European and French level. Since 2020, we are part of the Next40, and a few days ago, it was confirmed for the year 2021. That is a good information. So now let me show you a 2-minute film in order to know a bit more about Ynsect, about our objective, about our mission, how we can imagine to reinvent the food chain.
Founded in 2011 in Paris, France by scientists and environmental activists, Ynsect is the world leader in natural insect protein. The company transforms insect into premium high-value ingredients for organic animal feed and fertilizers. By 2050, we will need to increase food production by more than 70% to meet the needs of people globally. Yet only 5% more arable land is available. Ynsect thus provides a natural and sustainable solution by offering an alternative protein using 98% less land and 50% less resources. Welcome to the first Ynsect factory. We implement an innovative proprietary technology protected by 30 patents to develop our vertical farms, allowing us to farm our insects with a low surface impact and a carbon negative footprint. The vertical farm is fully automated by robots feeding, hatching, acidifying, and finally processing the insect protein. Our company develops AI models as well as computer vision to create the optimal environment for insect production. It currently produces hundreds of tons of tenebrio-molitor protein, oil, and fertilizer for the trillion-dollar animals nutrition and agriculture markets. Ynsect employs a highly talented global workforce, over 130 people from 20 countries in France and in the US, to tackle current and future feed, food, and environmental challenges. Ynsect is building its second production site 1 hour north of Paris, the largest insect farm in the world, which will produce up to 100,000 tons per year. By 2022, the project aims to create 500 direct and indirect jobs. It will also be the first carbon negative vertical farm in the world. Ynsect has been rewarded with more than 50 prizes and distinctions, placing us among the companies considered to be the most innovative and attractive by the French government and press globally. Ynsect, reinventing the food chain.
So as mentioned in the video, we are facing different kind of issue and challenges all over the globe. I will not come back to the point that I already mentioned in the video, but it comes at the end to limited resources, do more with less, climate change, biodiversity, and in order to tackle this kind of issue, a circular economy is the solution, and we need to find alternative and sustainable resources. The insect class is the most important class that exists on Earth. It represents 50% of the overall species that are currently living on Earth. So a huge amount. Within these also species, there is Coleoptera 40% of it. And the scarab monitor mealworm is part of Coleoptera. There's also other species, but in fact, at the end, at the moment, for the moment, we in the insect business rear only 7 species. Scarab monitor mealworm, black soldier fly, cricket, for example, are on the very top of the insect that are usually reared. Saying that, there is a huge potential, sure, and there is some other things to explore for the future. But I would like to underline that insects bring innovative, natural, and sustainable solutions, as mentioned in the film. The second point also, it's something very important because in the circular economy, the insect that we rear in our company and in other company also allow to recycle various byproducts coming from agriculture that some people call waste, even if they are not waste, because we don't use waste in Europe, we use byproducts. And we, in fact, recycle this byproduct, generating substances, elements with high value like protein, oil, or another element like this. In addition to that, with the technology we develop at Ynsect, in vertical farming, for example, we also have a positive impact on the environment locally, because in fact we save land and we produce, in fact, just at the figure, 100 times more than a normal, let's say, usual animal farm. 100 times more efficient. And also concerning ocean biodiversity, as you probably know or don't know, fish are usually feed with other small fish that are fish on the oceans. So in fact, we contribute to save a part of the ocean livestock, avoiding or trying to avoid 20 or 25% fish that are collected to feed large fish. So insect is a huge potential. The insects are huge potential. And sure, at Ynsect, we have selected the mealworm, the scarab monitor, and we rear it with a patent process that allow to be an alternative for animal feed, animal protein in animal feedstuff, plant and soil, and also for human food. Some figures also that were mentioned also in the film, but I will underline 2 or 3. There is a health benefit also on a growing benefit for the fish, for example, 35% of rainbow trout yield, for example, and minus 40% of shrimp mortality. It's just for example, it's based on researches and studies that we have performed with independent university in Greece, in France, and in Germany, for example. Okay, so as a conclusion of this part, that is the why basically and the beginning of the solution, our objective is a bit ambitious, but it's to revolutionize the food chain at every level of the food chain. And thanks to science and technology applied in an industrial project, we would like to be able to do that and to combine, in fact, our science and technology within a vertical farm that we already have and we will continue to build right now and in the near future. In addition to that, reinventing the food chain is also to assure the transition of insect mealworm from a secondary food source to a primary one for human consumption. So, as we know, in Western country, a few years ago, it sounded a bit weird and surprising to be able to one day to eat insect or to eat ingredient coming from insect. But in fact, not for 2.5 million inhabitants all over the globe in Asia, in Africa, or in Central America, we usually eat insects. So the issue, in fact, that exists and exists less and less, it was a regulation, and we'll speak about, and also the behavior that we have in a Western country in order to accept to eat insect directly or indirectly. We do it indirectly because when we eat fish, for example, that are fed with insect, insect participate to this kind of food chain. So though demand is undeniably growing, there is of course a reservation from the global population, and but there is good reason now to be more than optimistic to use insect directly in the human food. So, in fact, as I mentioned before, there is two points that were barrier, let's say, to be able to feed directly human with insect. One of the barrier is the behavior. The second one is the regulation. So the regulation, as you probably know, for the people that are connected with this kind of business, Europe, EFSA, the authority about safety in Europe, is newly favorable for the use of some insects for human food. And especially for mealworm, it was mentioned a few days ago, it needs to be, let's say, officialized by the European Commission, but we are quite optimistic that it will appear during this year in order to allow insect producer of mealworm, scarab monitor, to enter within this business. And it will give also an opportunity for all the insect industry, because in the insect industry, even if we can be competitors in different areas, we are federated within the EPIF federation in order to promote our solution for the future. And we are waiting for the official agreement. That is a novel food dossier that we have already transferred to the Europe authorities. From our point of view at Ynsect company, the opportunity and added value in human food is mainly on nutrition and health. It means sport, muscle regeneration, senior elderly people. From premium ingredient, healthy food, and perhaps one day to a people menu to have it on the table. But in fact, our key objective is to address what our mealworm is able to do. In fact, is to provide, as mentioned in the bottom part of the presentation, natural protein, very rich protein, 72%. It's what the highest protein rate in all insect categories. Well-balanced amino acids, high digestibility, and a very low allergen risk. So this ingredient, mealworm protein, is really a solution for this kind of business. Nutrition, health, and is a key technical ingredient. As mentioned before, in Europe, but not only, we are at the moment applying for a dossier in US too. So, sure, there is let's say, a reason why we do that. There is some solution that we have. Scarab mealworm is one of them. But to succeed in this kind of business, science and technology is not enough. Definitely, we need the support of investors. We need to have clients, science and technology already mentioned, and people's skill and commitment too. And at Ynsect, we combine those different elements already. It is what I call the success factor, basically, to come from a startup to a real enterprise that will be able to deploy its solution all over the globe. So finance and support, as you probably know, it was mentioned in the media all over the globe also, with more than 800 articles worldwide. We have the financial support, and we have a total financing amount of $425 million from investors all over the globe, in Europe, in Asia, in America, with a very successful one that everybody know, one part of the Avenger. We have also the support of the European Union and national and local authorities through the project that we manage. We at that stage in the Ynsect company, we have already $105 million of contract already signed with the client in different areas. In the wine business, our fertilizer, organic fertilizer for the wine business. In aquaculture, as mentioned, because aquaculture is a huge business in Europe and all over the globe. And also fertilizer for jardin, for garden, for these kind of things with other partners. Pet food, sure. And now human food, and we have already signed a contract in human food. In terms of science and technology, because it is a fundamental thing of our business, we have around 30 patent family representing 250 patents all over the globe. The larger R&D center in insect industry located at Genopole, one of our partners. And also, and last but not least, the largest insect farm in the world that is under construction. You can see a picture here. It will be almost like this. It is the vertical farm 4.0 because fully automated with IoT inside and huge effort, let's say, in terms of automation. We will produce 100 kilotons of ingredient per year with our objective 200 kilotons, and the production will start early 2022. In addition to that, last but not least, we are carbon negative in this vertical farm in the north of Paris at Amiens. We have performed a study with independent organization because at Ynsect company, everything we do inside, we want to validate them with independent or academic organization. And the calculation obtained is minus 10 kilotons of carbon, and we will continue this kind of effort, not only about carbon, but about all other kind of resources that we need to produce our protein or our products. And as mentioned, it's a bit of clin d'oeil, as we say in French. We start at 4, we are now 150. Well, at the end of the year will be 250, and we hope to deploy, let's say, our solution over the globe, and we will generate, for example, at Amiens, 500 local jobs that will participate, let's say, to the social community and to the environment in that region. So, in terms of research and development. Just before presenting our in-farm vertical farm, in terms of research and innovation, it is with very various dimensions, let's say. Sure, insect husbandry, that is the fundamental thing for us and for our colleagues also from other company. In terms of nutrition, health, and genetic, we have, let's say, the best in class. We combine with key partners on Genopole also and all over the globe for this kind of subject. Let's say we manage also all the rearing techniques on geoengineering that we transfer at scale in a vertical farm, because it's good to do it in a lab, but it's better to do it in a huge and important factory in order to tackle these global challenges mentioned at the beginning. We also develop biotechnology with high value molecule and substance concentration coming from our insect scarab molitor mealworm. And in addition to that, by ourselves or with partner, we develop infrared technology, imagery, and the other are quite obvious, temperature and humidity. But all these sensors are within our vertical farm, partially in Dole, in Burgundy, and completely in our new factory, new vertical farm in Amiens. IoT, and also last but not least, because there is also data analyst and data scientist in our kind of business. It's a fundamental part, and one of our founder is a part of that team. Data science is very important for us. We analyze everything from cradle to grave, let's say, the early beginning of the research and development to the very end, in order to have a better understanding of everything in our business. So from R&D exploration to industry operation, we integrate everything in vertical farm to generate premium products, innovation and application for field, plant, and human food. To finish the presentation, I will propose a little film that will summarize a part of our process and a part of our solution that will exist in the near future in Amiens, and that we'll have to deploy all over the globe in order to contribute to reinvent the food chain. Here it is. So as a conclusion, if you want to participate in this adventure, do not hesitate to contact us, and do not hesitate to join us if you think that you have added value for reinventing the food chain. Thank you.
Thank you very much, Frank. You have a very complete and very interesting presentation. You have already a lot of questions. So we are very proud that the Ynsect is at Genopole, and we can see that everything start and still continuing to increase at Genopole and in the rest of the world. That's very interesting. Just for the audience, we will take only 3 questions per company, and we'll address that at the end of this of all the presentation for all the company. So anyway, now let's go to another company, nextProtein. They joined Genopole 1 year ago, and so we are very proud also to have them on Genopole. And let me give the floor to Etienne Reynaud, which is the head of strategy at nextProtein, and also Chloe Bruce, that she's a senior researcher from nextProtein.
Thank you for having us. First, I'd like to start by thanking Genopole and the team for setting up this event and inviting us to participate in this conversation on the latest trends in our industry. I realized that in the audience we have a few members of our industry, or people that are simply very knowledgeable about what our industry stands for. But I'll start with a brief recap of what our industry is and has accomplished, and the unique value proposition that nextProtein has. And then I'll let my colleague, Chloe, our nutrition specialist, to deep dive in our approach and strategy when it comes to raw materials and animal nutrition. So nextProtein is a project that's now a bit more than 5 years old. We're headquartered in Paris, and we have our first 2 production facilities in Tunisia. nextProtein was born out of the ambition, essentially, to tackle 3 challenges. The first one is the projected global protein gap. By 2050, we'll be around 10 billion people on the planet. And as a result, demand for protein will increase by a factor of 2. So considering our food system today and how stretched they already are, we're incapable of facing that demand as is. Not only do we need to produce more protein, we also need to produce it more sustainably. If you look at our conventional sources of protein, so for example, soya production, which has led to widespread deforestation, or fish meal, so fish protein production, which has led to the depletion of our fish stocks in both oceans and seas, not only we need to produce more proteins, we need to produce them better. Last but not least, food waste. Currently around the world, we're wasting around 30% of all the food that's being produced. So urgently, we need to learn to reintegrate these nutrients in our food systems. So that's how our industry, the insect farming industry, emerged in this context. Insects emerge as a solution to all 3 challenges. Insects can feed on any type of waste. So from manure to fruits and vegetables to cereal byproducts, insects are very flexible. Not only they're flexible, but they're also extremely efficient at converting that kind of waste. If you look at their food conversion ratio, if you look at the land requirements, water requirements, CO2 emitted per kilo of protein produced, insects are unbeatable compared to all the conventional sources of protein. If you look at beef, if you look at soya, and so on. More interestingly, if you look at our industry today, the vast majority of players have chosen the black soldier fly to get started. And there is a reason for that. If you want to target the commodity market, so the demand of protein in agriculture, in pet food, in poultry, and so on, there are 2 reasons that made BSF the preferred choice. The first one is the life cycle. If you look at the BSF, the life cycle is a bit more than 30 days. And not only is it better economics, it's also operationally safer. If you have any problem in your production, you can replace a batch in a short amount of time, which is not the case with other insects. For some of them, it will take double that amount of time. The second factor that explains why the BSF is becoming more and more adopted around the globe is going to be the feedstock flexibility. The BSF can feed on an extremely wide array of organic waste. So again, fruits and vegetables, cereal byproduct, and so on, whereas other insects are going to be more limited. So this has made the BSF basically fit for any environment. In this context, nextProtein developed quite a unique business value proposition, with a heavy focus on cost efficiency. We did not choose Tunisia, and we're not going to choose countries like Tunisia by accident. Tunisia was a strategic decision, mainly due to the fact that temperature-wise, climate-wise, it has almost optimal condition from an insect development perspective. We get their optimal temperature, which is 25 degrees or 77 Fahrenheit, 8 months out of 12. In France, where we have our headquarters, we would get that 2 months out of 12 tops. So in terms of energy bill, we have been able to drastically reduce it through our location. Second, technologically, we made the decision to develop most of our equipment and processes in-house, so as to become less CapEx intensive, and more importantly, to be able to constantly improve these equipment and processes as we go, to constantly be in a position to reduce costs. Then last but not least, raw materials. And I think that's what makes us the most unique at the end of the day. nextProtein decided on day one to focus on raw materials, waste actually, not byproducts, that are widely available and that have no uses, thereby making them widely affordable. We want to focus on waste that are literally not used and that would have otherwise ended up in landfills, so as to reintegrate them into our food systems. So again, our choice to go for fruits and vegetables presented several challenges, and I'll let my colleague Chloe detail them in a few seconds. But it has also made us extremely adaptable and flexible in relation to raw materials, so that we can project ourselves nowadays in any environment and integrate whatever waste we can find in all corners of the globe. So that's it for the overview, and I'll let my colleague Chloe detail our strategy in terms of raw material and insect nutrition. Thank you.
Thank you, Etienne. So I'll now detail what makes nextProtein unique and just develop a bit more what Etienne just explained. So first, let's have a glimpse at our process. So we design a process that is by nature highly efficient and which maximize circularity. As explained, we're recycling organic inputs and fruits and vegetable waste that are locally available in Tunisia. We are located in a quite strategic location, since all the fruits and vegetable waste are collected less than 20 kilometers away from the factory. And from those waste, we design an optimal feed mixture, which is provided to the larvae. Those larvae come from flies, which are raised at a stable density, and eggs are collected daily to ensure synchronous hatching. And those larvae grow and are fed during about a week with this optimal feed mixture. Then the larvae are sieved to separate the insect frass, so the insect frass and remaining substrate, from the larvae. Some larvae are saved to be reintroduced into the fly cages, so the cycle starts again. And the remaining larvae are used as products, so they are killed, hygienized, and a mechanical extraction is done to separate the protein powder, a fine protein powder out of larvae, and the insect oil. And both ingredients, so we call them next meal and next oil, can be incorporated into animal feed. So it could be feed for pet food, fish, or poultry. The third product that we produce is NextGrow. So it's basically insect frass, and it has some amazing properties to improve soil fertility. It also improves microbial life around the roots, and it increases water retention. So basically, it's giving back to the ground insect frass. And it's a positive circle to increase yields locally of the plants that are treated with NextGrow. So we are actually highly competitive because we leverage fruits and vegetable waste, and this has huge advantages because we're dealing with huge volumes. As Etienne just mentioned, fruits and vegetables are widely available around the world, and it's an untapped resource, meaning that in many places, they usually end up in landfills. In Tunisia, for example, there is no methanization path. So it's a pure waste. So our unique proposition is to recycle this waste and to have a sustainable start in our production system. It also enables us to have access to a very affordable resource. And so that makes us really competitive. The last advantage is that we are able to replicate our process in many locations in the world. So that makes us as well replicable. Yet, we have to deal with an amazing diversity because fruits and vegetables are by nature really diverse. We have to deal with seasonal variability. It's obviously not the same types of fruits and vegetables which are available during winter and during summer. All fruits and vegetables globally have a very high water content that we need to manage to obtain an ideal texture. And we deal with a great diversity of nutrient composition. So it's not an easy raw material yet, because we target stable end products, an homogeneous feed texture and a nutritious feed, we developed an extensive understanding of black soldier fly nutrition, and we are now able to adapt our feed preparation process to ensure stable end products, whatever the variability we get in our inputs. And that's really one of our strengths. To better learn how to deal with black soldier fly and this variability, we developed significant capabilities in research and development. So we have capabilities both well, in France and in Tunisia. In France, we can perform trials at lab scale with a team of 5 researchers located in Genopole. And in Tunisia, we have access to a pilot plant, which is actually really amazing to confirm hypotheses, but also deal with the daily challenges of the factory. And so both scale nourish each other, and that's really interesting to have this approach as a research. Here are a few examples of Rng initiatives. So about larvae metabolism, the goal was to unravel larvae metabolism and to identify essential nutrients for the larvae. This is key because if we know what nutrients are essential for insects, then we're able to adapt the feed mixture and provide exactly the right amount of each fruit and vegetable waste that we collect. And so we are able to set up in any newer environment and to deal with any kind of raw materials we can collect. We also studied quite extensively the impact of feed content on the final product composition. This is essential to better understand how we can ensure to have stable end products, but also how feasible it is to tailor the nutrition system on the products to target specific industries, for example, aquaculture. We also have other ongoing projects that I won't detail here about how to better optimize the feed mix preparation. So it can be working more on what components of the feed can be digested versus what is left over, on what kind of pre-treatments can improve even more the digestibility of the feed. It can be also about how to adapt the feed texture, because texture is absolutely key for insects' normal development, but also for the process. We need to have a consistent texture. So those were just few examples of research and development projects that are ongoing. And to give you now a bit of perspective of where we're going, in 2025, we're aiming to reach 100,000 metric tons of installed capacity in several corners of the world. So it could be South Asia or North America, and this will be achieved with several factories set up in those areas. So far, we are expanding in Tunisia. So we had this pilot plant of 400 metric tons of installed capacity ready, and we are now expanding with a second factory, but that's only the beginning of the journey. So thank you very much for listening to us. And please feel free to contact us on any of our platforms. You have everything on this last slide. We'll be happy to discuss with you. Thank you.
Thank you. Okay, still there. Okay, thank you, Chloe. Chloe?
Yes.
No, thank you. Thank you very much. You are still on, you have to stop to script. Okay, thank you. Perfect. Thank you, Chloe. Thank you, Etienne. It was a great presentation again. In regard with Ynsect, we wish you all the best, and we are here to help you in your development. You know that already. So let's talk another subject, another species. We go from Ynsect to small bacteria with Altar, and let me introduce you with Simon Trincard, who is the CEO of Altar. This company is on Genopole for almost 5 years now, and we are very proud to have Simon and Altar on Genopole. So Simon, the floor is yours. You can go.
Thank you. I cannot turn on my camera, but it's not very important. I'll first try to share my screen. Okay. Okay, can you hear me?
Yes.
Can you see the screen?
Yes.
We can hear you and we see you as well.
Okay, so let's start. Okay, so hi everyone. My name is Simon Trenkard. I'm co-founder and president at Altar. And as Laurent said, we're based in Genopole, Evry. We're a biotech startup. We work with microorganisms. And I'd like to thank for the invitation by IAR, it's hard to talk in English, and Genopole to talk about domestication of microorganisms for sustainable food production. So we go from insect to microbes, and I will make a presentation which is on purpose a very anthropocentric perspective, because at the end of the day, sustainability is not to save the planet, but to save humans, right? So I would start with a statement is that it is in human nature to take nature as granted. What does that mean? It means that we believe that every living organisms around us as they are, and they cannot change, and we have to cope with them, and we have to use them as they are. Recently, the coronavirus situation has made everybody aware that it is not true because of the variants, and this dynamic living process is not only a threat, it's actually also a lot of opportunities to develop sustainable alternatives to produce what we need every day. And when it deals with microorganisms, which has very high potential to convert renewable or recycled feedstocks into valuable compounds, it often leads to prohibitive production costs because the engineering of the bioprocess has to be adapted to what the microorganism is capable to do. And we consider that the microbe has given characteristics, and then we design the process with these constraints. And this explains why there are so few industrial processes involving microorganisms around the world that can efficiently convert to renewable and recycled materials when compared to the potential. And we propose to shift the paradigm and no longer adapt the process to the microbe, but instead adapt the microbe to the industrial needs. But before that, I'd like to talk a bit about domestication, because this is actually a human activity that started 15,000 years ago, according to which human will interfere in the natural process of selection, natural selection, to pick living organisms with desired properties to meet humans' needs. And that's how we have domesticated animals and plants for a while, and even microbes for more recently, but so for thousands of years. And which is very interesting is that it is very powerful, because from a common ancestor like a wolf, we were able actually to select for a very wide array of different dogs that have distinct phenotypes. They look differently. They also have different behaviors. And it shows that by applying the appropriate selection pressure, we can specialize different variants according to our criteria. The same occurs for microorganisms, which are domesticated for maybe 5,000 years. And the most commonly used microbe is yeast Saccharomyces cerevisiae. And this is a picture which shows how evolution may be represented in terms of phylogenetic for 628 strains, according to their domestication for food and beverages utilizations by humans. And which is interesting is that it highly depends on the geography. And one reason may be because it was unintentional first, because during thousands of years, we were not even aware of the existence of microbes. So it was like unintentional domestication. And a main reason for that is maybe the size of the microbe, because when we compare to a wolf, which is a meter size, or even to a Tenebrio molitor bug that insect uses in its process, which you can see and you can easily isolate and select, a bacterium is 1 micrometer scale. So it's 1,000,000 times smaller than a wolf. You cannot see, and you can not easily, even when you know it exists, you cannot easily isolate it and select them. So, but in turn, microbes are very good also properties, and the size is also very interesting as a benefit, because it means that in a reasonable volume, you can gather a very large population. And if you think about evolution, it means that you will be able to create a large diversity in reasonable volumes. And another factor is also the pace at which the organism reproduces. So we've heard before that Tenebrio molitor is maybe 2-3 months. The bug by nextProtein is maybe a month, but a bacterium, it duplicates every hour or every 2, 3, 4 hours. So it means that in a given time period, you will have much more generations that are crossed by a bacterium when compared to other organisms, which means that if you want to achieve very significant objectives in terms of domestication, you can achieve them easily with bacterium or other microorganisms when compared to longer generation organisms. Still, the potential has to be explored, because the activity to isolate microorganisms and work with them at the lab is very recent. And the first pure culture of microbes that was isolated was by Emil Christian Hansen at the Carlsberg Brewery, and he's isolated lager bee yeasts. And we are still learning on how to cultivate strains, pick among the diversity, isolate, grow them, and adapt them to our needs. So we're still at the beginning, and the potential of microbes, which is huge, still has to be explored in our opinion. So what would be the challenges to domesticate them? So first is, as I mentioned before, they are small, invisible, and if you want to grow them and manipulate them, you must work in sterile conditions with invisible organisms. And sterile conditions are mandatory, and you may know that you have microbes everywhere on your bench, on your skin, and so it's a potential limit. How we can change microbes? So we could harness natural selection, but what kind of diversity will be generated? And you're probably aware that there is a significant advance in genome editing tools in the last years, which become more and more affordable, more and more efficient, more and more versatile. However, it's not sufficient, because somebody has to tell you which modifications you must perform in the genome to achieve the targeted phenotype. And for certain applications, and the food industry in Europe at least is a very good example, is that GMOs are banned either by regulation or in consumers. So how can you generate this diversity, and how you can select among the variants? So that's the very important questions that you have to address while domesticating microbes. And at Altar, we try to keep it very simple so that it can be efficiently implemented. And we design hardware and software in order to have nature working for us, so that we can help nature to eventually help us humans. So we are involved in an activity of research and development that aim to have strains of industrial relevance And we develop them in partnerships with our customers and other collaborators using a proprietary technology for adaptive evolution. And it is, in our views, a very nice tool. Because again, when you consider the challenges I've mentioned before, you must have the right tool to cope with microbe. And it's important to start working with the appropriate equipment, the appropriate technology. And so we've spent the last years, maybe it was 20 years of development to achieve a robust and reliable technology that now is ready for use for your project and to deliver results, which is strain adapted to the industrial requirement. So what it is a fluidic device, which is fully standalone. It means it works autonomously without any interruption, so with no contamination, as long as necessary, provided you can replace empty bottles by new ones. And these devices enable the continuous cultivation of microbial suspensions under conditions controlled by algorithms. So it means that you can perform a long-term experiment, long-term being 3, 6, 9 months, you tell it. And during this period of time, we will go through hundreds, thousands of generations because they are thriving quite fast. And conditions will change automatically, adjusted by the actual adaptation of the microbe. And only the microbes that can adapt to the changing conditions will be selected. And this is a very powerful tool that has proven to be relevant for any kind of microbe that can grow in suspension, ranging from bacteria, yeasts, or microalgae. And this is used to support strain development projects in very wide range of market industries. We provide access to academic and private organizations that develop strains for agriculture, food and feed, health, chemicals, or biofuels. So if we look at sustainable production, which is the topic today, actually there are microbes involved in feeding and protecting humans, animals, plants. It can be fermentation to produce flavor and fragrances, vitamins, enzymes, proteins, or you can use probiotics for humans or cattle. It can be biostimulants or biocontrol solutions to replace fossil-based pesticides and fertilizers. So there are several applications that can be addressed by microorganisms in the entire food chain. And here I'd like to focus a bit on one application, which is the single cell protein, because today we told a lot about insect proteins, but microbes also have a good potential for it. And it's actually a very long story because the research started a century ago, and we already had industrial scale production of single cell proteins, which are microbial cells that contain a high content of proteins. And Germany, during World War I and II, produced alternative proteins this way to counteract the food shortages during war. And later on, during the 60s and 70s of last century, there were even programs to convert fossil-based resources into single-cell protein. So now the challenge is different. We must be more sustainable, otherwise the world will be unbalanced. And we are looking for alternative feedstocks, which can be locally available, renewable, or recycled. And there is a number of projects that can grow single-cell protein from glucose or for second-generation sugars that are obtained from lignocellulose, or even from C1 molecules, CO2, CO, methane, or methanol, that are developed around the world. It's a growing business, and there are several companies involved. And you may have heard last month that Air Protein US company raised $30 million to develop microbes that can convert CO2 into protein. So it's a very dynamic field. And we've worked on one project of this type on single cell protein yeast that was given to us and was already quite good at utilizing C5 sugar coming from lignocellulose. But still, we were able to further increase growth rate on that sugar by 45%, about 2 months, and therefore increase the productivity of our client's process. I've put here another example of application of our technology to domesticate E. coli to grow at lower temperature. So E. coli grows well at 37 degrees Celsius, but if you put at 28, it grows very slowly, but we can select for mutations that will enable the strain to grow faster and faster and recover the growth rate at 37 degrees in about 6 months. And this may be of interest to food and beverages companies that want to develop fermentation processes at low temperature without to lose productivity. And last, it's just to mention that we were involved in a probiotic project to develop a bacterium that can be used as a human probiotic and that can degrade a toxic compound. And we could select for faster and faster utilization of this toxic compound as a nutrient source. We achieved a 7-fold increase in growth rate within 6 months, and later it continued with adaptation to other inhibitors. And eventually the bacterium is much more adapted to the requirement because it can develop with the gut, dominate in the microbiome population, and have an efficient and prolonged action. So there will be several other things to tell, but I think I should finish now. I hope you enjoyed the presentation, and I will be glad to answer your questions.
Thank you, Simon. Yeah, very interesting. You know, as you know me, I love this kind of subject about genetic, you know, domestication. Everything is very, very interesting. Anyway, so now let's go on question. So let me start with one for Ynsect and nextProtein finally, because you know this subject is for both of those companies. So so the first question is, what do Ynsect or maybe nextProtein believe will limit insect protein production going forward? Do you believe that there is enough food waste to support insect production on a global scale? Or do you think we need to find new sustainable insect feeds? What do you think about that? Frank, go ahead.
I can start. Well, in fact, we are a little part of a global solution that is huge. First of all, let's say the market business in terms of feed and fertilizer is $1,000 billion. So there is a huge opportunity for our kind of business, nextProtein, Ynsect, and other insect producer. The market is huge. The source also, the feedstock that we use is considerable. We speak usually about waste, but in fact, just in brackets, waste in Europe is something that is really regular with high regulation. So it means that when we speak about byproducts or when we speak about waste, we need to assure a perfect traceability of what we use as a feed for insects. We cannot use in Europe manure or waste of industries that we don't have under control. Perhaps in other countries like this, but in the insect industry, at least in Europe, there is a huge legislation on that. And to come back to the question concerning the feedstock, byproduct or waste, there is tons and tons of possibility. Cereal mainly for the coleoptera, votre tenebrio mealworm, and cereal it is produced and byproduct from cereal that are not with very low value at the moment are all over the globe. concerning fruit and vegetables, but I will let nextProtein complete. There is a huge also opportunity. So our business at Ynsect is not to feed our insect with a pure, let's say, ingredient, is to use, in fact, what have very low value in our business on Earth for the moment, and to generate high value protein or these kind of things.
Thank you, Frank.
No limit.
No limit. Okay, great. So what do you think, Chloe? What is your point about?
Yeah, well, I agree. I think most of the elements were said by Frank, but to complete on that, 1/3 of food is wasted so far. So it's a huge amount that is available. And so far we are limited to fruits and vegetables, but who knows tomorrow what we could use as well as new resources. Even if from a regulatory standpoint, we're limited to pre-consumer plant-based byproducts, who knows tomorrow what would be available. So far, at least, we have really more than enough waste available and byproducts available to reuse, and nothing to produce at all to feed insects.
Yes.
Okay, great. Maybe a question for Simon. Yeah. So I have one very simple question first for you to start. It's is your technology an alternative to genome engineering, or it is used to improve only modified genetically bacteria or?
Yeah. So in our machine, we mostly rely on natural mutations. So it is suitable to develop non-genetically modified organisms. However, historically, the technology was developed to support metabolic engineering projects, and it's a nice tool to actually fasten the development of such projects. But we see that there is more and more demand on the non-GMO aspect, and today we have maybe a 50-50 of both.
Okay, thank you very much.
I have maybe noticed one question for Frank, maybe. Why scarab monitor mealworm is the insect for human food consumption? Why have you chosen that one and not another one?
In fact, we start at the beginning with mealworm because of different reasons. And then sure, now I will answer to your question, but we come back to the original. We didn't choose at the beginning mealworm for this special purpose. We chose mealworm because mealworm have huge capability in terms of feedstock, in terms of process, and in terms of output. I will come back to that point later. But concerning human consumption, the opportunity, let's say, it is the mealworm is one of the insects that generate a higher level of protein, 72% with the insect way of rearing the mealworm. There is other insect that can produce protein, but not at that rate. It is one of the points. The second point, let's say, is we have identified in aquaculture, in pet food, that beside the protein rate, there is also a health benefit. Sometimes we just measure it in aquaculture, for example, on bass or on shrimp, as far as I remember. And we also perform some research on rats. When we feed with an independent university in Germany, we feed rats, fatty rats, obese, with a protein coming from mealworm instead of other animal protein. And it has a very positive impact, 70% decrease on cholesterol and on bad, let's say, lipid. So, and at the end, we come to the point that there is an opportunity for human food. In addition to that, the European authority at the moment only authorize the mealworm as an entire insect It will be officialized in the following weeks. There is first an assessment, and after the final decision will come in the following weeks. And our, let's say, process and our business is to produce ingredients for mealworm. So, and the allergenic level, let's say, of a part of the insect, especially protein, is probably or most probably lower than the entire insect that is considered as safe by Europe. So it means on different level, it's more than an opportunity. It's an option in the future.
And what about nextProtein? Why have you chosen, or why are you working with fly?
So as Etienne mentioned, so black soldier fly are actually an insect that is often chosen by the industry because of the short life cycle that it has. And the second main big advantage is the flexibility in terms of feedstock. I think we insisted quite a lot on this aspect during the presentation, but so its ability to feed on various resources, on whatever waste we receive, is an amazing advantage. And so that's why we decided to go for this insect specifically.
Okay, thank you. One question for Simon. I guess maybe you have seen it. It's about bacteria to produce protein. What do you know if there are any advance in enzymatic hydrolysis of lignocelluloses? Do you have some data about that? Are you working?
Yes, actually the global cost of the process is the accumulation of different steps, and what has been limiting was also the cost for producing the sugars from the lignocellulosic. So there are different kind of treatments as far as I know, and enzymatics are maybe the most popular. What I think that, again, the process could be optimized, meaning that if you have to cool down a lot what enters in your fermenter, it costs very, very much. But if you adapt the strain to higher temperature and tolerate all the byproducts that are generated in the enzymatic process, at the end of the day, you can simplify your whole process and diminish the cost. So again, I'm not very aware of the progress on that enzymatic processes, but what we receive are demand to adapt the strains to the real feedstock that comes from the pre-treatment, and there is a lot to do, I would say.
Okay.
And, what about selection of insect using your technology, Simon? Is that something you can work on it, or are you working on it? Just to conclude a little bit with this webinar, maybe as a last question.
No, I think it will be a very huge gap. Well, we like microbes that swim in water and aqueous solutions, so to say. But I think that there are potential synergies because maybe insects can be fed with microbes, or the diet of the insect could be supplemented by microbes. Or I think that there are a lot to do with this. And I think that nextProtein mentioned that one of their products is also used to feed the microbes in soil. And so there are a lot of interactions eventually, and it's a whole ecosystem. And I think that our mission is to open opportunities and maybe to create new interactions.
Exactly. I don't know if they have bacteria in their guts.
Yes, they do.
Yeah, they do. So yeah, so you can work. You can work on it.
Yeah, we could do probiotic for insects.
Exactly. Why not? Why not? That's a good point. Okay, thank you. I think it's time to finish, Johan.
Yes, it's time to finish now. Thank you. I would like to thank Genopole and all the invited speakers for sharing their expertise. I think now everyone can understand a little bit more about what they are doing, how they do it, why they do it. and we understood that they are not going to save the planet, but at least they contribute to save humanity on the planet, because the planet itself will probably survive to humanity. And what you have to do now is to make sure that we survive in the planet as long as possible. Again, I hope you did appreciate our webinar, and we invite you to participate to the next webinar on March 9, dedicated to plant-based protein purification. I saw there was one question about protein purification on the chat. Maybe you participate to our next, let's say, webinar to have replies on that. If you are interested as well in breakthrough technology to turn biomass into high-valued molecule, don't forget neither our digital edition of BIOKET. Nail, Laurent, many thanks for this cooperation. Frank, Chloe, and all the speakers, Simon as well. Thank you very much. I wish you a very nice afternoon, a very nice day for those who are living in North America. And thank you, and see you soon. Bye-bye.
Thank you very much, everybody.
Do not hesitate to contact us.
Exactly.